Classification of elements, the periodic table, 10th class physical science in a chemistry chapter. Important topic for 4 marks. How does atomic radius vary in groups and periods in the modern periodic table, and what is atomic radius? Important topic for 4 marks. Variation of characteristic properties of some elements in groups and periods. First one, what is atomic radius? Atomic radius can also be called atomic size. Atomic radius can also be called atomic size. But what is the definition of atomic radius? For example, we are taking a sodium. You know its atomic number is 11. Its electronic configuration is 1s2, 2s2, 2p6, 3s1. So it has 3 shells. It is a shell number 1, this is a shell number 2, this is a shell number 3. So it is the nucleus of sodium atom. It is the first shell. It is the second shell, it is the third shell. Now, it is the center of the nucleus, it is the outermost shell in sodium atom. So, from here to here, this distance is called atomic size or atomic radius. So, the distance from center of the nucleus to outermost shell of an atom is called atomic radius. Atomic radius can also be called atomic size. So now we can write the definition for atomic size or atomic radius. Atomic size or atomic radius. The distance from center of the nucleus to outermost shell in the atom can be called as atomic radius or atomic size. It is the definition for atomic radius or atomic size, student. So, distance from center of the nucleus to outermost shell of an atom is called atomic radius. It can also be called atomic size. Now, what are the units to measure atomic size or atomic radius? Its units are one is angstrom unit. Angstrom unit is denoted by like this, a power 0. So 1 angstrom unit equal to 10 power minus 10 meters. 1 angstrom unit is 10 power minus 10 meters. So it is important for bits. And the second one is also there. It can also be expressed in nanometers. Nanometer in short form can be written as nm. So 1 nanometer is equals to 10 power minus 9 meters. And third one is 1 picometer. Picometer can be written as pm. 1 picometer is equals to 10 power minus 12 meters. So these are the units which we use for measuring atomic radius or atomic size. So this is a answer for what is atomic radius. Now here it is there. How does atomic radius vary in groups and periods? So in the modern periodic table, how does atomic radius or atomic size change in the group from top to bottom and in a period from left to right? Important question for 4 marks or 2 marks. Important question for 4 marks or 2 marks. So now variation of atomic size or atomic radius. So first one, variation of atomic size or atomic radius in a group in the modern periodic table. Students, you know, in the modern periodic table, vertical column is called a group. What is a group means? In a modern periodic table, vertical column is called a group. So there are 18 groups in the modern periodic table. So those are denoted by Roman numbers 1 to 8. Each one has a subgroups A and B, or also Arabic numbers from 1 to 18. So now atomic radius, how does, so a variation of atomic radius in a group from top to bottom. For example, we are taking first A group elements like hydrogen, lithium, sodium, potassium, like that we are taking. In the group 1A, some elements we have taken. First element in the group A, hydrogen. Second element in the group A, lithium. Third element in the group 1A is a sodium, and fourth element in the group 1A is potassium. Its atomic number, you know, 1 and it is 3, it is 11 and it is 19. Now we are writing its configuration, students, electronic configuration: 1s1, 1s2, 2s1, 1s2, 2s2, 2p6, 3s1, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So now you can see in the 1A group from top to bottom, it is a nucleus of hydrogen and it is its first shell, and this is its size. In the second one, lithium, it is a nucleus of lithium and it is a first shell. So hydrogen has only one shell, lithium has a 2 shells, sodium has a 3 shells, 1, 2, 3. Potassium has 1, 2, 3 and 4. So you can observe, you can see when we come down from top to bottom in the group like hydrogen, lithium, sodium, potassium, number of shells increases. 1 shell, 2 shells, 3 shells, 4 shells. So in a group, atomic size or atomic radius. So this is atomic radius for lithium. Now we are taking a sodium. It is the first shell. This is, and this is, and this is. So this is a distance or atomic radius. So from this we can understand, in a group from top to bottom, atomic radius increases. In a group from top to bottom, atomic radius increases. Bottom to top means decreases. So reason for this one is, from one element to another element, atomic number increases and number of shells also increases. So how does atomic radius vary in a group means, atomic radius in a group from top to bottom increases because increase of atomic number and also increase of number of shells from one element to another element. This is the reason. So now we are going to write answer for this one, students. Variation of atomic radius in groups and periods is the main concept to write how does ionization energy vary in groups and periods, electron affinity in groups and periods, electronegativity in groups and periods. So all those can be explained with the basic concept of atomic radius, students. So now in a group from top to bottom, atomic radius or atomic size increases because two reasons. One is because increase of atomic number, and another one main reason, increase of number of shells from one element to another element, This is, so in a group from top to bottom, atomic radius or atomic size increases because increase of atomic number and increase of number of shells from one element to another element. So with one example from group 1a elements like hydrogen, lithium, sodium, potassium, like that we explained atomic number increases from top to bottom, and also from one element to another element number of shells also increase. For example, hydrogen 1 shell, lithium 2 shells, sodium 3 shells, potassium 4 shells, like that number of shells increases, distance from center of the nucleus to outermost shell also increases, students. Next to variation of atomic radius in a period. So here variation of atomic radius in a group means top to bottom increases, bottom to top means decreases. Bottom to top means decreases, top to bottom means increases. Next to in a period, how does atomic radius vary from left to right? Now variation of atomic radius in a period in the modern periodic table. Students, in the modern periodic table, in the previous video we explained what is a period. In the modern periodic table, horizontal rows are called periods. So there are 7 periods in the modern periodic table. Those are denoted by Arabic number from 1 to 7. So each period has some definite number of elements, like a first period 2 elements, second and third each one has 8 elements, fourth and fifth each one has 18 elements, and sixth period is a 32 elements, and seventh period is incompleted period. So those information bits were explained in the previous video, so you can see and you can understand. So variation of atomic radius in a period, horizontal rows are called periods. So period means we want to take a left to right or right to left. In general we take a left to right. For example, we are taking first period. In the first period, first element is hydrogen and second element is helium. That is left to right in a period. Period means horizontal row along the x-axis, students. Its atomic number is period number 1. This is its atomic number 1. Its atomic number is 2. Its electron configuration 1s1, it is 1s2. It is a nucleus of hydrogen, and this is. It is a nucleus of helium, and here it has a 2 electrons. It is 1s, it is 1s. There 2 electrons, there 1 electron. So now here you can see but here it is drawn bigger and here it is drawn smaller. The reason for this, here one shell, there is no change in number of shells from one element to another element in a period from left to right. Hydrogen atomic number 1, atomic number 2. Atomic number increases, but no increase of number of shells from here to here. One shell. But in the same shell, number of electrons increases. Here in the first shell, only one electron is there. Here in the first shell, 2 electrons are there. That is why here number of units of negative charge, number of units of positive charge increases. Here only 1 unit of positive charge, 1 unit of negative charge. Here 2 units of positive charge, 2 units of negative charge. So here 1 proton and here 1 electron. But here 2 protons and 2 electrons. So 2 units of positive charge and here it is a 2 units of negative charge. That is why attraction between nucleus and outermost shell increases so that size decreases. But here same shell number is not increased, 1 and 1. But in the same shell number of electrons increases. That is why in a period from left to right atomic size or atomic radius increases. The reason for this one is no addition of extra shell from one element to another element. At the same time, in the same shell, number of electrons increases so that the attraction between the nucleus and outermost shell increases. That is why atomic radius decreases. But in the case of groups, shell number increases. That is why distance from nucleus to outermost shell increases so that attraction decreases. There atomic radius increases from top to bottom, but here decreases from left to right. So in a period from left to right, in a period from left to right, atomic radius or atomic size decreases because no addition of extra shell from one element to another element. At the same time, you can also understand at the same time, in the same number of shell from one element to another element, number of electrons increases. That is why attraction between the nucleus and outermost shell increases so that atomic radius or atomic size decreases. So don't forget students, this is a basic concept to explain variation of ionization energy, variation of electron affinity, variation of electronegativity in groups and periods in the coming topics. So what is atomic radius? How does atomic radius vary in groups and periods? Most important topic. So in the next video, what is ionization energy and how does it vary in groups and periods? We explain. So for more topics, so follow this channel, subscribe the channel.